welcome to my channel Kuluru Vineeth. So we'll continue the arrays playlist. So today's question is moving zeros to end of the array. So this is what the question looks like. So we are given an input array consisting of 0 elements and non-zero elements. So our goal is move zeros to the end of the array, right? That is our goal. So here let's take an example here. We have given an example as 0, 4, 1, 7, 0, 67, 34, and at the end our output should look like this. As we see, the zeros are at the end of the array, right? The question is clear. Now coming down to the simple intuition and approach that we could come up for this question is, well, straightforward. What I will say is I'll take two lists, one for non-zero elements, another for zero elements, and at the end I'll add both of them. That would give me our required answer, right? So let me write down that approach. Use separate elements. Okay, so let me name this as approach 1, and our input will be integers array, and return type is, let me make it as list of n. Okay, so I will take first the two arrays. One is, let me name this as non-zero elements, which I will use to store non-zero elements, and this is this one, and also take zero elements, that is I'll use this array to store zero elements. Okay, now I will traverse the array and check if the current element I am at is 0. I will push into this 0 elements array, else what I will do is I will push it to non-zero elements array. Okay, finally at the end of the traversal, what I will do is I will just add non-zero elements and zero elements unwritten. That would give us the concatenated list, first having the non-zero elements and second having zero elements, which is what exactly we need, right? So this is the approach 1 for this question. Now coming down to the time and space complexity, as we see, we are using two extra arrays to store zero elements and non-zero elements. Space complexity would be order of n. And coming down to time complexity, since we are traversing array once, our time complexity would be order of n. So let me write down that here. Time complexity is order of n, and the space is order of n. Fine. So this was our approach 1. Now, is there any other approach that we could do it without an extra space? As we see in the previous approach, we have dealt with multiple extra arrays. Like, can we do it inbuilt in space array? Yeah, we could do that. Okay, yes, we could do that. So let me write down that approach. Approach 2, traverse and swap elements. Okay, here it is. So let me name this as approach 2, and it would be int array, and return type would be same as the above one, right? So here what it is, I will traverse just a second. Yeah, I will traverse nums indices and check if nums dot indices, what we do is, if that nums of I is equals to 0, we will take one extra variable and take next index and compare this with the whole size of the array and check if this is equals to 0. I will keep moving this forward, and finally what I would do here is I would just swap the elements nums of I with nums of j, and the nums of j I would replace with 0, right? And finally return nums. Wait a second, so I'll convert this into list, right? So nums dot to list, right? Simple, right? So this is straightforward. Swap the elements and keep looking for the non-zero elements and swap with the 0th element. So this is the approach 2. Now coming down to the time and space complexity, I would say time is order of n, since we are traversing array once, and space is order of 1, since we are using just one temporary variable, right? So this was the approach 2 for this question. Well, again, is there any other approach that we could come up with for this question? Well, I would say there is a directly partition function based on particular element that we can partition. Here the partition element would be a 0, right? And at the end add partition first and partition second. So let me write down that approach as well. Using partition function. Okay, so let me pull this up. Let me name this as approach 3, and here again, just a second, input parameter remains same and the return type would also remain same. Here just the thing is we can partition. Let's store this into this, so I can directly use partition based on 0th elements. So what it will do is it will create a partition based on the element we have specified. Here it is 0, so that means non-zero elements will be partitioned against the 0 elements, right? So now what I'll do is I will create new list of integers. So new list, so name this as mutable list of int, then, or else, no, I would directly do this nums dot, fine, no problem. I will add all partition dot first and add all partition dot second. So here partition dot first will have the non-zero elements and partition dot second will have 0 elements. So this is what exactly we needed, right? So and finally what I'll do is I will return this one, right? Simple. This was the approach 3, which will give us our desired result. Now coming down to the time and space complexity, time is order of n, partition behind the scenes same as we have written above, and space complexity is order of n, since I am using extra array to add a new partitioned elements. Yes, so these were the 3 approaches that we could come up with this question. Okay, so now let's me write the main function and start executing each of the approaches and compare the output of each approach. Okay, so let me take an example, same the above one which I have shown, which is this one. Okay, and use it here, and now also initiate the object of above class I have created. Okay, so this is not just a second, right? So initiating the above class I have created, and now let me collect the result of each approach into a separate variable and then print each of them and compare result of each approach. Okay, so let me call respective of functions, and then I'll use to print approach 1, and you iterate in the for loop, and finally not in separate line, so I'll just use print here and do the same for approach 2. Okay, so let me do that. Just change the naming conventions, and here it is, change, and do the same for approach 3 as well. Just changing the names to respective approach. Okay, now let's execute and check what the output of each function looks like. Looks like we moved out of bound. Where exactly? Here. I guess so. Just a second. So here, instead of now, let me try it this way and check now what this gives us. Execute this. Still, just a second. Nums are fine. I'm trying to increment it. Okay, here I forgot to check if j is still less than this. That is only when we would do the check. Okay, I guess this should resolve our problem here. Yeah, did I print? Okay, I think here no need for ln. I think I should use here. Okay, and do the same for other approaches as well. Just printing a separate line so that they will be properly printed out. Okay, so now let's check. Yeah, as we see, the output for approach 1, approach 2 and approach 3, we have moved all zeros to the end of the array. Yeah, so this is it for this video. Thank you so much for your love and support. Keep watching and keep supporting. There will be a lot more exciting content coming up on your way every day. Thank you so much.